Section 5.7, Mass Calculations for Reactions. In this section, we're going to be applying what we learned in Section 5.2 and 5.6 and putting it all together with our balanced equation. You'll notice it says the guide to calculating the masses of reactants and products in a chemical reaction. We're going to use the molar mass to convert grams of given moles if necessary, and that we learned back in Section 5.2. Then we're going to write a mole-to-mole factor from the coefficients in the equation. We just got through learning that from 5.6. Then we're going to convert from moles of given to moles of needed using the mole-to-mole factor. That is what we just got through learning in 5.6. And then from that, we're going to convert from moles of the needed substance to the grams using molar mass, which is just going back to Section 5.2. Again, you can see we're putting it all together. Here we go. Using the following equation, determine the mass of NH3 that can be produced from 32 grams of nitrogen. So you'll notice we have several steps here, so this is going to continue for several slides, but they give us an equation. So when they give you an equation, that usually means you're going to need to use it. Now then, the first thing we're going to do is they give us 32 grams of N2. So that means we're going to have to convert to moles of N2. And we do that by looking at the periodic table, finding that the number for N is 14, but we have two of them, so it is 28 grams of N2. Now we can write it either way, 1 mole of N2 over 28 grams of N2, or 28 grams of N2 over 1 mole of N2, but we got to do it the right way. So let's write what we are going to start with. That's the 32 grams of N2. So we start with that. Now then we immediately notice in order to cancel out the grams of N2, then the conversion that we're going to be using is the 1 mole of N2 over 28.0 grams of N2. That way the label grams of N2 cancels out. So that is 32 times 1, so it's 32 divided by 28.0. All right, at this moment we get 1.1 moles of N2. We're not done. We're a fourth of the way through. So now then we're going to then do what we learned in Section 5.6, which is figure out the mole-to-mole ratio for the coefficients for the two items that they're mentioning. So they mentioned nitrogen, they mentioned ammonia. So you'll notice here there were some numbers. Let's see. When we look at our equation, the coefficient in front of the nitrogen, there is none, so that's understood to be 1, and the coefficient in front of the NH3 is 2. So that's where, in step 2 here, where they get those numbers. So obviously we can put the 1 mole of nitrogen over the 2 moles of ammonia, or vice versa, the 2 moles of NH3 over 1 mole of nitrogen. Let's see which one we need to. Well, we were, at the end of step 1, at 1.1 moles of N2. So we know then we have to cancel out the moles of N2. That's why we're going to need to use the ratio of 2 moles of NH3 to 1 mole of N2. So the moles of N2 cancel out. So then when you do that math, you get 2.2 moles of NH3, and you think, oh great, I'm done. No, because the question wanted to know how many grams of NH3. So now then, we're going to go back and going from moles to grams. So we look up the molar mass of nitrogen. It's 14, hydrogen is 1, but you got 3 hydrogens, so that's a total of 17 grams for every 1 mole of nitrogen, of ammonia. And so we got the 14 from the nitrogen, we've got the 1 for the molar mass from hydrogen, but we have 3 of them, that's where we come up with the 17 grams. So for every 1 mole of NH3, it is 17.0 grams of NH3. So you think, oh, can I just use that? No, look here. In step 3, right back there, we ended up with 2.2 moles of NH3. We're not done because it asks for grams of NH3, so we're going to go from 2.2 moles of NH3 over 17.0 grams of NH3 to over the 1 mole of NH3. So the moles cancel out. You will notice what the label is, grams of NH3. So you do the math, 2.2 times 17.0 grams of NH3, and you have 37 grams of NH3. And you go, well, am I done yet? Well, yes, you are, because you got to grams of NH3, which is what they asked for. Now, I personally like to do it all in one long series of steps, which I'll show you at the end of this section, but I think that they're using this in individual steps so that you are aware of the thought process. So, let's try this one. How many grams of O2 are needed to produce 45.8 grams of iron 3 oxide in the following reaction? So, let's see. we are asking for our O2, and they're giving us our Fe2O3. So these are the two items we're going to be looking at. So the first thing we're going to do is we are going to have to go from 45.8 grams of Fe2O3 to moles of the Fe2O3, so that then we can use our mole to mole ratio of the 2 moles of Fe2O3 to 3 moles of O2. At that point, once we're at moles of O2, we can then convert to grams of O2. So let's look at it step by step. So step 1, use molar mass to convert grams of given to moles. Well, we have 45.8 grams of iron 3 oxide. When you look up the molar mass of Fe2O3, you will see that it's 159.7 grams. So we could write it either way. And so then you write it the way that it's going to use to cancel out the labels. 45.8 grams of Fe2O3. Now we know that this label grams of Fe2O3 must go on the bottom. So the ratio, so we're going to have the 1 mole of Fe2O3 on top and the 159.7 grams of Fe2 on the bottom. So when you do that math, you're at moles of Fe2O3. So you go, oh, am I done? No. Notice it says how many grams. So only when we get to the label grams of O2 are we done. But we're now at moles of Fe2O3. Now we can use our equation to go from moles of Fe2O3 to moles of O2. And the coefficients in front of those, we had a 3 in front of the O2, we had a 2 in front of the Fe2O3. So then you go, well, which one's going to be on top? Well, look to see. At step 3, we were at, so let's actually go back to step 1 for a second. You will notice we were at 0.287 moles of Fe2O3. So as we continue, 0.287 moles of Fe2O3, when we're using our mole to mole ratio, the moles of Fe2O3 must be on the bottom so that the label cancels out. So then we're going to go 0.287 times 3 over 2, and we're going to get 0.430, and the label that's left is moles of O2. Again, you ask, am I done? No, it asks for grams. So we're going to take now then the 0.430 moles of O2, and using the molar mass, convert it to grams. When you look up the molar mass of oxygen, of just O, it's 16, but remember we have 2 of them. So 16 times 2 is 32. So we can either use 1 mole of O2 is 32.0 grams of O2, or 32.0 grams of O2 is 1 mole of O2. So you go, well, which one's which? Well, look to see where we were at on our last problem. We were at 0.430 moles of O2. So that's where we're going to start. That means, that forces us to use the conversion that has the mole of O2 on the bottom. So 32.0 grams of O2 over 1 mole of O2. So the moles of O2 label cancels out, and we're going to go 0.430 times 32.0 equals 13.8 grams of O2. A reaction between H2 and O2 produces 13.1 grams of water. How many grams of O2 reacted? So let's see. Go ahead and press pause. See how far that you get. All right, you're back now. Well, we have 13.1 grams of water. We need to get to oxygen. So the first thing we have to do is go from grams of water to moles of water. Then we're going to go from moles of water to moles of O2 by using the coefficients of the 2 in front of the water and the 1 in front of the O2. Well, I know there's no 1 in front of the O2, but it's understood to be 1. And then once we're at moles of O2, we are then going to convert to grams of O2. So we starting with what they gave us, 13.1 grams of water over 1 mole of water is 18.0 grams of water. When you do that math, the labels cancel out, the grams of water cancel out, and we get 0.728 moles of water. So now then we are going to use, now that we're at moles of water, we can then convert to moles of O2. And we're going to use the coefficients in front of our O2 and water on that equation in order to do that. We know that we have to have the moles of water on the bottom so that this label cancels out here. So we have 0.728 moles of water times 1 mole of oxygen over 2 moles of water. So the moles of water cancel out. We get 0.728 times 1 divided by 2, and we get 0.364 moles of oxygen. Now all we have to do is convert to grams. So we look up the molar mass of oxygen at 16, but we have 2 of them for our O2, so 32 grams of O2. So we have 0.364 moles of O2. We know we're going to have for every 1 mole of O2, it's 32.0 grams of O2. We know we need to have the label moles of O2 on the bottom so that it cancels out here. You will notice when you multiply through now, the only label you have left is grams of O2, and that is exactly what they were asking for. So you do the math, and you are now at 11.6 grams of O2. So press pause, see if you can do this. All right, so this is really how I like to do it. I like to do all these different steps on one piece of paper, one right after another, so I can see and keep track. On the 2 examples that we showed you before, we did each step individually, and to me, you might get lost along the way. But now that you know each step individually, let's go ahead and do all of these steps together. So they ask for grams of HCl, and they said we are going to start with 5 grams of MnO2. Now then you look up the molar mass. For every 1 mole of MnO2, you've calculated that it's 86.9 grams of MnO2. All right, so you're going to put that label there so that our grams of MnO2 are going to cancel out with the grams of MnO2 there. Now, notice if we've only done step 2, we now are at moles of MnO2. We have to convert to moles of HCl by using our equation, and that number back here has none here, which means a 1 and a 4 in front of that. So we need to put the moles of MnO2 on the bottom so that the label cancels out to every 4 moles of HCl. And remember, we're going to get these numbers right here in our multimole ratio from the equation, and that's the only time we're going to be using our numbers that we've used to balance the equation, those numbers in front in our math portion here. Okay, so now then, the moles of MnO2 have canceled out, the grams of MnO2 have canceled out, we're now at moles of HCl. We need to convert to grams of HCl, so you look up the molar mass of chlorine is 35.5, the hydrogen is 1, you add it together and you get 36.5 grams is the mass of 1 mole of HCl. By putting it this way, the moles of HCl will cancel out, and the only label you have left is grams of HCl. So now you're going to multiply 5 times 1 times 4 times 36.5, all divided by 86.9 times 1 times 1. And when you do, you get 8.40 grams of HCl.